Lesson 1. Gravity and Friction. Reading Guide. Key Concepts. Essential Questions. What are some contact forces and some non-contact forces? What is the law of universal gravitation? How does friction affect the motion of two objects sliding past each other? Vocabulary. Force. Contact force. Non-contact force. Gravity. Mass. Weight. Friction. Inquiry. Why doesn't he fall? This astronaut is on an aircraft that flies at steep angles and provides a sense of weightlessness. Why doesn't he fall? He does. Earth's gravity pulls the astronaut down, but the aircraft moves downward at the same speed. Types of forces. Think about all the things you pushed or pulled today. You might have pushed toothpaste out of a tube. Maybe you pulled out a chair to sit down. A push or a pull on an object is called a force. An object or a person can apply a force to another object or person. Some forces are applied only when objects touch. Other forces are applied even when objects do not touch. Contact forces. The hand of the karate expert in Figure 1 applied a force to the stack of boards and broke them. You have probably also seen a musician strike the keys of a piano and an athlete hit a ball with a bat. In each case, a person or an object applied a force to an object that it touched. A contact force is a push or a pull on one object by another that is touching it. Contact forces can be weak, like when you press the keys on a computer keyboard. They also can be strong, such as when large sections of underground rock suddenly move, resulting in an earthquake. The large sections of Earth's crust, called plates, also apply strong contact forces against each other. Over long periods of time, these forces can create mountain ranges if one plate pushes another plate upward. Non-contact forces. Lift a pencil and then release it. What happens? The pencil falls toward the floor. A parachutist falls toward Earth even though nothing is touching him. A force that one object can apply to another object without touching it is a non-contact force. Gravity, which pulled on your pencil and the parachutist, is a non-contact force. The magnetic force, which attracts certain metals to magnets, is also a non-contact force. In Figure 2, another non-contact force, called the electric force, causes the girl's hair to stand on end. Key concept check. What are some contact forces and some non-contact forces? Strength and direction of forces. Forces have both strength and direction. If you push your textbook away from you, it probably slides across your desk. What happens if you push down on your book? It probably does not move. You can use the same strength of force in both cases. Different things happen because the direction of the applied force is different. As shown in Figure 3, arrows can be used to show forces. The length of an arrow shows the strength of the force. Notice in the figure that the force applied by the tennis racket is stronger than the force applied by the table tennis paddle. As a result, the arrow showing the force of the tennis racket is longer. The direction that an arrow points shows the direction in which force was applied. The SI unit for force is the Newton, N. You apply a force of about 1 Newton when lifting a stick of butter. You use a force of about 20 newtons when lifting a 2-liter bottle of water. If you use arrows to show these forces, the water's arrow would be 20 times longer. What is gravity? Objects fall to the ground because Earth exerts an attractive force on them. Did you know that you also exert an attractive force on objects? Gravity is an attractive force that exists between all objects that have mass. Mass is the amount of matter in an object. Mass is often measured in kilograms, kg. The Law of Universal Gravitation. In the late 1600s, an English scientist and mathematician, Sir Isaac Newton, developed the Law of Universal Gravitation. This law states that all objects are attracted to each other by a gravitational force. The strength of the force depends on the mass of each object and the distance between them. Key concept check. What is the law of universal gravitation? Weight. A gravitational force. Earth has more mass than any object near you. As a result, the gravitational force Earth exerts on you is greater than the force exerted by any other object. Weight is the gravitational force exerted on an object. Near Earth's surface, an object's weight is the gravitational force exerted on the object by Earth. Because weight is a force, it is measured in newtons. The relationship between weight and mass. An object's weight is proportional to its mass. For example, if one object has twice the mass of another object, it also has twice the weight. Near Earth's surface, the weight of an object in newtons is about 10 times its mass in kilograms. Reading check. What is the relationship between mass and weight? Weight and mass high above Earth. You might think that astronauts in orbit around Earth are weightless. Their weight is about 90% of what it is on Earth. The mass of the astronaut in Figure 6 is about 55 kilograms. Her weight is about 540 newtons on Earth and about 500 newtons on the space station, 350 kilometers above Earth's surface. Why is there no significant change in weight when the distance increases so much? Earth is so large that an astronaut must be much farther away for the gravitational force to change much. The distance between the astronaut and Earth is small compared to the size of Earth. Reading check. Why is the gravitational force that a friend exerts on you less than the gravitational force exerted on you by Earth? Friction. If you slide across a smooth floor in your socks, you move quickly at first and then stop. The force that slows you is friction. Friction is a force that resists the motion of two surfaces that are touching. There are several types of friction. Static friction. The box on the left in Figure 7 does not move because the girl's applied force is balanced by static friction. Static friction prevents surfaces from sliding past each other. Up to a limit, the strength of static friction changes to match the applied force. If the girl increases the applied force, the box still will not move because the static friction also increases. Sliding friction. When static friction reaches its limit between surfaces, the box will move. As shown in Figure 7, the force of two students pushing is greater than the static friction between the box and the floor. Sliding friction opposes the motion of surfaces sliding past each other. As long as the box is sliding, the sliding friction does not change. Increasing the applied force makes the box slide faster. If the students stop pushing, the box will slow and stop because of sliding friction. Fluid friction. Friction between a surface and a fluid, any material such as water or air that flows, is fluid friction. Fluid friction between a surface and air is air resistance. Suppose an object is moving through a fluid. Decreasing the surface area toward the oncoming fluid decreases the air resistance against the object. The crumpled paper in Figure 8 falls faster than the flat paper because it has less surface area and less air resistance. What causes friction? Rub your hands together. What do you feel? If your hands were soapy, you could slide them past each other easily. You feel more friction when you rub your dry hands together than when you rub your soapy hands together. What causes friction between surfaces? Look at the close-up view of surfaces in Figure 9. Microscopic dips and bumps cover all surfaces. When surfaces slide past each other, the dips and bumps on one surface catch on the dips and bumps on the other surface. This microscopic roughness slows sliding and is a source of friction. Key concept check. How does friction affect the motion of two objects sliding past each other? In addition, small particles, atoms and molecules, make up all surfaces. These particles contain weak electrical charges. When a positive charge on one surface slides by a negative charge on the other surface, an attraction occurs between the particles. This attraction slows sliding and is another source of friction between the surfaces. Reading check. What are two causes of friction? Reducing friction. When you rub soapy hands together, the soapy water slightly separates the surfaces of your hands. There is less contact between the microscopic dips and bumps and between the electrical charges of your hands. Soap acts as a lubricant and decreases friction. With less friction, it is easier for surfaces to slide past each other, as shown in Figure 9. Motor oil is a lubricant that reduces friction between moving parts of a car's engine. Look again at the effect of air resistance on the falling paper in Figure 8. Reducing the paper's surface area reduces the fluid friction between it and the air.